All right, here is your section 7.1 recap video. So for section 7.1, we were introduced to hypothesis testing. A hypothesis test is a process that uses sample statistics to test a claim about the value of a population parameter. A statistical hypothesis is a statement or claim about a population parameter. They need a pair of hypotheses, one that represents the claim, the other the complement. And when one of these hypotheses is false, the other must be true. So we need those two statements. So the first one we call the null hypothesis, a statistical hypothesis that contains a statement of equality, such as less than or equal to, or greater than or equal to. It is denoted by H naught, red, H sub 0, or H naught. All right, the alternative hypothesis is a statement of inequality, such as greater than, not equal to, and less than. It must be true if H naught is false, and vice versa. It is denoted by HA, red, H sub A. So as you notice, these statements are complementary statements, because if it's less than or equal to, the opposite of that is greater than, and so on and so forth. And that's how these things are set up. So to write the null and alternative hypothesis, translate the claim made about the population parameter from a verbal statement to a mathematical statement. Then write its complement. All right, there are three possible choices we have. So we can have that the naught is less than or equal to, the alternative is greater than or equal to, the alternative is less than, and if H naught is equal to, then the alternative is not equal to. Regardless of which pair of hypotheses you use, you always assume mu equals k and examine the sampling distribution on the basis of this assumption. This is your test statistic for the first type that we're going to be doing, and this is kind of like your constant or your part in your problem that you're discussing. So the alternative hypothesis, HA, contains less than inequality symbol. So if we're looking here, this is what we call a left-tailed test. It's less than and it's left-tailed. The right-tailed test is if the alternative hypothesis contains greater than inequality. And it looks like this. Here's our test statistic, and P is the area to the right of that test statistic. And this is a right-tailed test. Now, a two-tailed test is if the alternative hypothesis, H sub A, contains the not equal inequality symbol. Each tail has an area of half of P. In this case, we would have two test statistics, and each area here is twice the area. One half the area, not twice. Write the claim as a mathematical sentence. State the null and alternative hypothesis and identify which represents the claim. We're also going to discuss if it's left or right-tailed here. So a university publicizes that the proportion of its students who graduate in 4 years is 82%. So when we look at this, we know it's two-tailed because our hypothesis is the probability is equal to 0.82 because it says it is 82%. So alternative for that is that it's not equal to 0.82. That is the complement. This is our claim as well. Write the claim as a mathematical sentence. So a water faucet manufacturer announces that the mean flow rate of a certain type of faucet is less than. So less than has to do with our alternative hypothesis. Also, we know less than means it's going to be left-tailed. So it's left-tailed, and our alternative is less than 2.5 gallons. That is our inequality condition, and this is our claim. Now, if this is less than, this has to be the opposite of that, which is greater than or equal to, and that is the complement of H sub A. Here's another example. A cereal company advertises that the mean weight of the contents of its 20-ounce size cereal boxes is more than 20 ounces. If it's more than, that means it's to the right. That means it's right-tailed. That also means our alternative hypothesis is greater than 20 ounces. That is our claim. If it's greater than, then that leaves us to be less than or equal to for our null hypothesis. All right, so there's a couple other things we need to discuss. There's the level of significance. So your maximum allowable probability of making a type 1 error, which I will discuss in just a moment, is denoted by A, the lowercase Greek letter alpha. By setting the level of significance at a small value, you are saying that you want the probability of rejecting a true null hypothesis to be small. Commonly used levels of significance are 0.1, 0.05, and 0.01. This is alpha, which is also 1 minus the probability, so these are also commonly used in the previous chapters as 90%, 95%, and 99%. So our p-values are very important as well. The probability, if the null hypothesis is true, of obtaining a sample statistic with a value as extreme or more extreme than the one determined from the sample data. It depends on the nature of the test. So we have to make a decision given all this information that we have. So compare the p-value with alpha. If p is less than or equal to alpha, then we're going to reject our null hypothesis. If p is greater than alpha, then we're going to fail to reject our null hypothesis. All right, so if we look at these claims down here, if we reject the null hypothesis, there is enough evidence to reject the claim. There's enough evidence to support the claim for the alternative if we reject this one, because if we reject one, the other one must be true. So what if we fail to reject H naught? That means there is not enough evidence to reject the claim. That also means there is enough evidence to support the claim. All right, so a type 1 error occurs if the null hypothesis is rejected when it is true. A type 2 error occurs if the null hypothesis is not rejected when it is false. So a type 1 error is rejected when it is true. So that means something is true and we accidentally think that it's not true and we've caused some kind of issue. Type 2 error occurs if the null hypothesis is not rejected when it actually is false. Well, so let's take some kind of medication for some instance, that a certain medication causes heart diseases. Well, what if we don't reject it, which means we say it's okay, but it actually really does cause those heart diseases? That's a type 2 kind of error. So examples of interpreting a decision. You perform a hypothesis test for the following claim. How should you interpret your decision if you reject H naught? Or if you fail to reject H naught. So the claim is a university publicizes that the proportion of its students who graduate in 4 years is 82%. We've already discussed this one. So first we have to represent our claim, and if you reject H naught, you should conclude that there is sufficient evidence to indicate that the university's claim is false. And if you fail to reject H naught, you should conclude there is insufficient evidence to indicate that the university's claim of a 4-year graduation rate of 82% is false. So let's interpret our decision. All right, you perform a hypothesis test for the following claim. So claim, Consumer Reports states that the mean stopping distance on a dry surface for a Honda Civic is less than 136 feet. The claim is represented by the alternative hypothesis in this case. So H naught is the mean stopping distance is greater than or equal to, because this one says less than. So if you reject H naught, you should conclude there is enough evidence to support Consumer Reports, because our claim is really the alternative. So we have to reject it in order for there to be enough evidence to support our claim. If you fail to reject it, you should conclude that there is not enough evidence to support our Consumer Reports claim that the stopping distance for a Honda Civic is less than 136 feet. All right, so we have 7 steps for our hypothesis testing. First, we need to state the claim mathematically and verbally, identify the null and alternative hypothesis, specify the level of significance, determine the standardized sampling distribution and draw its graph, calculate the test statistic and its standardized value, add it to your sketch, find the p-value, use the following decision rule. So you need to ask yourself, is the p-value less than or equal to the significance level? If it is not, you fail to reject H naught. If it is, you reject H naught, and that's your decision. And then we write a statement to interpret this decision in the context of the original problem. That is all for this review.